certificates for the workshop, but the condition is that you need to attend throughout for both the days. Like we'll be checking like if you have just joined and then you have left, so you won't get any certificates then. You'll have to be sincere and attentive and participate throughout the workshops, because the trainers are really taking in a lot of efforts to help you kickstart your machine learning journeys. So I am very excited to learn from Akshada and Aditya. I hope you all are. And now I'll hand over to Akshada to start with our today's session. Over to you, Akshada.
Okay, thanks Pratna for giving me this opportunity and like means make me. I'm Akshada Bhandari, working as a data scientist intern at Vasundhara Geotechnologies. I was previously working as a machine learning intern at iNeuron and a developer intern at Apartment Solutions. So basically, my entire journey is related to machine learning and playing around data. I am fully enthusiastic with data science. I love reading blogs related to it. We know that technology is growing every day, so we have to update ourselves with these technologies. In today's era, machine learning, data science, artificial intelligence are some of the best technologies where you can make your career superb. Just like it's going to be exciting, as well as you're going to learn a lot of things. Um, yeah, so the contents of today's workshop are, I'm going to introduce you to machine learning. Then we are going to check about the life cycle which we use for developing machine learning as well as data science projects. We are also going to have some look on algorithms, and we are going to have a use case. Like for example, I'm going to teach you an algorithm from scratch to building it, how to use for building products. So this is the introduction. Machine learning is a study of computer algorithms that can improve automatically through experience and by the use of data. So what we can say is, if we feed some data to a machine, it gives us some predictions, but over the time, using different algorithms, we can make it more accurate. For example, in the everyday use, we use Instagram every day. So a basic machine learning algorithm is implemented over there called as recommendation system. For example, if you watch reels of Tarak Mehta, you would be getting recommendations or items which are similar to it. So this is where machine learning comes into picture. And in today's world, there is no any sector where machine learning is not used. Okay, so we all have heard different terms like artificial intelligence, machine learning, data science, deep learning, computer vision, natural language processing. These all terms are different, but our end goal is to create a basic artificial intelligence application. Can someone tell me what is the difference between AI, ML, DS? Like whatever you know, just let me know so that we can have an interactive session.
Hello.
Well, AI is AI is something just like the advanced form of the machine learning. It includes use of multiple agents, while a machine learning is just a basic algorithm structure. It just utilizes only one single agent. For example, we utilize AI in game development, which includes various agents. Also, in DS, it's just like a basic algorithmic structure on which we work, I believe.
Okay, yeah, so you have a clear picture about what AI, machine learning, and data science is. So, do you use any AI applications in your day-to-day life?
Yeah, we do use camera, like mobile phone camera. If you put it in front of something, it tells us that it is a puppy or it is a plant or anything normal day to day life.
Okay, so that is an example of machine learning classification algorithm. So we would be looking out for a use case which is very much similar to classification. All right. So is there anyone who want to also share their experience about what the difference they do know?
Yes, ma'am. Alexa is also one of the example of AI/ML.
Yes, so Alexa is an example of natural language processing, which is an end product to create an artificial intelligence product. Anyone else?
Yes, actually, we can understand AI as a set in which ML and DL is a subset.
Yes, this is a perfect answer which I was expecting. So taking it forward, our end goal should always be creating an AI application. A basic AI application is what we are looking at. AI is a complete universal set. Like for example, if we are considering a Venn diagram, AI is the universal set. ML is a subset of AI and deep learning is a subset of machine learning. Data science comes in all these three fields. Basically, what is data science? Data scientist analyzes the data, looks at the patterns of data, and they have to work in all sectors. Like for example, if you are a data scientist, you should have basic knowledge about artificial intelligence, machine learning algorithms, deep learning algorithms, computer vision, natural language processing, and the list goes on. So in today's workshop, we would be looking out towards machine learning and data science. Deep learning will be continued tomorrow. So machine learning and its types. Machine learning is further divided into three parts, that is supervised, unsupervised, and reinforcement learning. These are different types of machine learning. Like for example, how we want our model to be interpreted. For example, now let's consider supervised machine learning. In supervised machine learning, we have the labeled data. Like we know what output we want. For example, when we consider a data set, three features. For example, if we are categorizing a student is going to pass or not. So we are considering three features. The time, the amount of time he plays, he studies, he sleeps, and the output we get is in the form of pass or fail. So this is where supervised machine learning algorithm comes up. Like we train the model with part of data set with the output values, and then we test it with our testing data set. Supervised learning is used for advertising popular. It's further divided into classification and regression. So in regression, we have it in advertising popularity prediction, for weather forecasting, for climate forecasting, for studying the trends of stock market forecasting. We can also get to know about our business development. And it is majorly used in classification. So in classification, we have a wide variety of applications. For example, diagnosis of disease, customer retention, image classification, and detecting the fraud or crime. The next technique which we have in machine learning is unsupervised learning. So in unsupervised learning, we don't have any output label. Like for example, in the first data set where we had the student as pass or fail. So here we don't have any kind of output variable. For example, clustering algorithms are one of the best unsupervised machine learning algorithms. They are basically used in finding the structures, marketing, customer segmentation, recommendation system is something where unsupervised learning comes into picture. Taking an example, for example, if I give you latitude and longitude, doing geocoding, we are going to get the location of a place. So this is where unsupervised learning comes into picture. For again, and in customer segmentation, we can take an example. For example, if a company is going to launch its new scheme, so they are going to categorize the scheme into three parts: rich, poor, and middle class people. So they are going to check it out whether rich are going to use in what way, middle class are going to use in what way, and poor people are going to use in what way. So they are going to target mostly on middle class as well as poor people, because the rich people stats is almost only 20% in India. So instead of taking an account those 20, we are going to take an account 80%. An example of this is Geo platforms, where they had launched their reasonable recharges for all people, so everyone could use them. The next is reinforcement learning. So reinforcement machine learning is completely a different field. It's very huge and it's difficult also. We can also call it as semi-supervised machine learning. initially the model is trained on label data. After training, we give the model new data. So it learns from new data. The learning process in reinforcement learning never stops. Taking an example, for example, a kid. During his childhood days, he is taught various things. Once he grows, he gets into different habits, be it eating, learning, walking, or anything. Now, for example, the kid is walking. Here, the thing is, we give reward to the machine. So, if he fails, he is punished, and if he passes, he is rewarded with some kind of prizes. For example, if a kid is walking on a staircase, if he falls, he starts crying, which is a punishment. Like, for example, if he gets hurt, that is a kind of punishment which he gets because of not walking properly. But once he gets trained, he gets an means he gets he starts walking properly. So he is rewarded in that terms. We can also take an example when parents, for example, your parents have many times told you, like, if you score this much marks, we would be giving you something, for example, a mobile phone. But if you don't, you're not given it. So that is a punishment. This is overall reinforcement learning. So if anyone is having any doubt in these three techniques, just let me know. Okay, I hope everyone is enjoying the session. Also, reinforcement learning is used in artificial intelligence robots where they are trained initially, but after that they learn on their own experiences. So reinforcement learning is used vastly for creating artificial intelligence products. So coming to the next part, that is deep learning. So deep learning is a subset of machine learning in which we work with neural networks. So scientists in 1980s had researched about mimicking the human brain so that the machine can give us predictions in more accurate way. In this way, deep learning was founded, and we have three basic neural networks, that is ANN, artificial neural network, CNN, convolutional neural network, RNN, recurrent neural network. So basically, this is everything about machine learning, deep learning, and artificial intelligence. Data scientist is a person who works in all these fields.
Hello.
Yeah.
Pardon me for the interruption, but I think if you are presenting the screen, it is not visible at all.
No, I'm taking it. I hope now the screen life cycle of projects is going on.
Now it's black screen.
Which one it is?
I think you need to check your network because I am able to see the screen. What about others?
Okay.
Yes.
I can see life cycle of MLDS projects.
Yeah, so that is the thing which we are having now. So we would be looking out when we are creating a data science project or machine learning project, we have to follow some steps. So starting with data selection. The most important part of machine learning project is getting a good data. And the data shouldn't be small also. It should be quite large enough. When we start working into a company, just a second. Sorry for the interruption. So basically in data selection, we have to get a proper organized data. It shouldn't be small, because if the data is small, when we take the model into production for testing, we are going to face issues like overfitting and underfitting. So to avoid that, we need a clean data. Now the data can be of two types. It can be real time or it can be a CSV file which we get in the companies. Real time data is something which we get from streaming platforms. For example, Twitter. Then we get from advertising agents. Also, we can consider news channels who give us lively updates. climate, that is forecasting, which we can use for predicting further, that is predicting the future. After selecting a data, we need to describe the data. For example, what kind of columns we are having, what features we are having, what we are going to predict with those data types. With the data, then we need to check on with the data types. Now, for example, if you're yes, does someone wants to say anything? All right, so we can continue with data description. So basically we describe the entire data set. We use various parameters. We do statistical analysis on them and do graphical data analysis. So in statistics, we try to find out the mean, median, mode, the quantile regions, that is 25, 50, 25, 50 and 75% of data, which helps us in detecting the outliers. Next, we do graphical data analysis. So basically, we try to plot as many as data graphs. For example, when we take a data science project, our entire, even though it's a simple project, we require a timeline of around 2 to 3 months. So the first week goes around data selection, second data description, third is doing statistical and graphical data analysis. Now, why this step is very important? If you do statistical analysis, you get to know how many outliers are present. But sometimes these outliers can be important data points also, which gives us a lot of information about anomalies. That is the important data. And graphical data analysis, we can get the relationship between the predicted value, the outcome which we are going to predict, and the features which we are having. So there are many graphs, like for example box plot, which helps us in finding out the outliers, the kinetic density graph, which helps us to understand the type of data, whether it is normalized or standardized. So depending upon that, we need to check with our own, we need to apply pre-processing steps. Now, data transformation, if it is necessary. Once we do this graphical data analysis and statistical analysis, we get to know our data in a more appropriate way. We get to know how many missing values are present, whether the data is going into negative side or it is staying into positive side. Then if any outliers are present, we need to remove them. And then we have to remove the missing values using mean, median, mode, or there are many, whether the data is balanced or not. So now as we have come to the point, data balancing. Data balancing is something like, for example, if you're having two classes as ones and zeros, that is yes or no's. And if yes class is only 20% and no class is 80%. So this can help us in giving wrong outputs. So for that reason, we need to balance the data. There are different techniques, for example, smart atomic, smart ENN, random oversampler, random undersampler, and many sampling techniques which help us in balancing the data. So this is all about data transformation. In data transformation, if you are having many batch files, like for example, if you are getting streaming data from company, we need to check the pattern of data files also. If we are training a model on 10 features and if the file which we are getting is around only 8 or 9 features, we need to drop that because it's going to give various problems into our further pipeline. So transforming the data is important. The next is selection of machine learning algorithms based on patterns which are observed in EDA. So we have to be very careful while choosing machine learning algorithms. For example, if you're solving a classification problem and you choose a regression algorithm, it's going to give you errors as well as wrong outputs, which can be very harmful and time consuming into entire pipeline. So selection of machine learning algorithms is very important. The next is data standardization and normalization. So here what we do is we scale the data using standard scalar library so that we get to know from the EDA itself. I'll be showing you into the use case which we are going to prepare. The next, now for model training, we need to split the data. So train test split is a library which we use for splitting the data set. Now there are parameters like in how many, in what percentage you have to split the data. So it ranges around 30, like we can split it accordingly, but it's always considered a good practice to keep it around 20, 25 or 30%. Also, there's a parameter called stratify where we pass the output, that is the y label, into it, so that if we are having 10 ones and 90 zeros, it also gets divided appropriately. Then model training. So once you split the data, we are going to train our data using the training data set. We train it using a simple algorithm, but once we get a good accuracy, we can do hyperparameter tuning. So in hyperparameter tuning, we use grid search CV algorithm and many more. So this helps us in getting parameters, appropriate parameters for a model. Once we get it, we are going to train our model again. It is proof that once we do hyperparameter tuning, we get more accurate results in our machine learning model. Now, building the model is not only a thing, we need to evaluate it. So the evaluation metrics are different for regression as well as classification models. In regression, we consider MSE, that is mean squared error value, whereas for classification, there are many. For example, confusion matrix, we have precision, recall, sensitivity, FN score, ROC, AOC curve. So these are the things which we consider while evaluating a model. Once a model is ready and is giving appropriate results according to us, we take it to deployment. So the deployment can be in any way. It can be deployed to a mobile application, onto a cloud server, into any AWS or GCP cloud platform. It can be also deployed into a website, which can be further taken into development. You can also integrate it with Dockers, Kubernetes, and all those things. Now, this was the life cycle of machine learning and data science project. If you have any doubts before proceeding further, we can solve it now. I hope anyone is not having any doubts. So we would be going further. Yeah.
Excuse me.
Yes.
Will you please tell again how we can deploy a model once it is trained?
So basically what we do means I have up till now stored a model into a pickle file. So there are some commands. We have to store the model in pickle file. Then whatever the parameters which we are getting, we are going to deploy it. We are going to means reshape it according to using NumPy, and we are going to pass this parameters to the model which we are loading into our web file. For example, the file operations which we use for reading or writing the data, in same way we are going to open the pickle file of our model, and then start deploy and then we are going to pass our parameters that we need to write some code. For example, now if we want to predict the if a person is affected with a disease or not, so what we need to do is we are going to get the answer in terms of zeros and ones. So we have to print the statements accordingly, like if the prediction is equal to 0, you are not affected, else you are affected. In this way the deployment goes. I hope your doubt is solved.
Yeah, thank you.
Yeah. Anyone else? Okay, so we would be moving. Yeah.
I think there are some doubts in the chat box.
All right, I'll check them. Just a second.
If you want, I can speak it out to you.
Yeah, that's better because I need to switch it.
Okay, all right, just a minute. Yeah, so Tehseen is asking if semi-supervised model is considered as a type of learning.
Semi-supervised comes under reinforcement learning. So reinforcement learning is a complete different branch of machine learning where we have a data set. For example, a robot. We initially teach the robot using different methods. For example, if we have to make him knowledgeable, we are going to make him read books, articles, blogs, news, etc. But when we are trying to reinforce it, that is when we are giving him rewards or punishments, he is going to learn on his own. The best example we can take is the Sophia model, that is the robot which was built in China.
Okay, thanks for answering, Akshada. There's another doubt from Pallavi. She's asking how to deploy a model using Streamlit.
Okay, so the step follows, it is the same step. That is, you need to store it in a pickle file, and then you need to design the web page and then deploy it. As I am not into deployment, I am completely into data science and machine learning track. I am not aware about deploying it to Streamlit, but this is the normal approach which we keep during deploying the models.
Okay, Akshita, great. Thank you. And to all the participants, it will be really great if you focus on the current content and ask the doubts on the same. Because like right now we are studying what is machine learning. So please ask doubts on the same and later on we can cover other doubts. Is that okay, Akshita?
Yeah, that sounds good. Okay, so as we are focusing today completely on supervised machine learning algorithm, we would be looking out towards classification and regression. So starting with classification. The classification algorithm is a supervised learning technique which is used to identify the category of new observations on the basis of training data. That is, we classify the models, we classify the outputs into the labels. For example, yes or no, 0 or 1, spam or not spam. In computer vision, if we are categorizing the photo as cat or dog. So these classes can be called as targets or labels or even categories. For example, in starting, one person gave an example. Uh, the identification of using camera, it identifies what thing is over there. So that is also an example of classification which is used in computer vision. So is this idea clear about classification?
Yes, ma'am.
All right. Just don't call me ma'am. You can call me Akshada. All right. So regression. Now, regression in statistics is the process of predicting a label based on features at hand. When we have to give the score, that is, we want the value in percentages, we use regression algorithms. For example, predicting the stock prices. It's not going to be into form of yes or no. It's going to be in the form of money. So that is where regression comes into picture. You all must be aware about the line formula, that is y is equal to mx plus c. That is the formula which is widely used in regression. For example, also we can see time series modeling, finding the causal effect relationship between variables and forecasting are some of the widely used areas where regression algorithms are used. For example, relationship between stock prices of the company, various factors like customer reputation and company's annual performance. These can be studied using regression. So these are the two algorithms which we use, two studies which we use in a day-to-day life. Okay, so we would be looking out towards the algorithms. I'm not going to go in a lot of deep into these algorithms because studying these algorithms involves statistics, calculus, mathematics, implementation, and parameters. So I would be just giving you an overview about what algorithms can be used where. So starting with supervised machine learning, we are having linear regression, logistic regression, support vector machine. So linear regression is used only for regression algorithms. Logistic regression is used for classification. Support vector machine is used for classification, and support vector regressor is used for regression. The next is naive bias. So in naive bias, what we do is we calculate the probability of the class, which is going to be, which is it's a type of conditional probability of the class which we are going to predict. Decision tree is similar to binary tree. So we create a decision tree of our features. We calculate the entropy and information gain, and the one which has, I guess, more information gain becomes the root, and then the tree is split up in this way. So the major drawback of decision tree is its formation, because it requires a lot of computational as well as time complexity. The next is random forest, ADA boost, gradient boosting, and XGBoost. So these are the derivatives of decision trees, where we use different operations like bagging and boosting. Different parameters are used for these, and these models are built. So even CART 4.5 is a type of decision tree which is used for classification as well as regression. The next is KNN. So K nearest neighbor. It is used to find out when we have the test data and training data, we plot the distance between the training data and testing data. So using Euclidean parameters, and then classify our predicted output. Time series, we have ARIMAs and SARINAs, which we use for predicting, which we used for weather forecasting, sales forecasting, as well as for stock forecasting. Unsupervised machine learning algorithms. So this is something tricky. Also, it's a bit hard to digest. K-means clustering is an algorithm in which we have clusters for different features. And we have DB scan, K nearest neighbors, PCA, that is principal component analysis. These algorithms are used for building unsupervised machine learning products. Okay, so we are going to look into deep for linear regression as well as logistic regression. Linear regression is a linear approach for modeling the relationship between a scalar response and one or more explanatory variables, which are also known as dependent and independent variables. The case of one explanatory variable is called simple linear regression, and for more than one, the process is called multiple linear regression. Now, as you can see a picture, this is where this is the mathematical approach for linear regression. Now we have the data points. For example, the red dots is our training data. Now, after using this, when we fit the model using linear regression, we are going to get Y test, that is, sorry, Y predictions for testing data, which we plot using some another color. Once we get those, we are going to draw a line. This is a blue line, which is called as best fit line, so that the distance between data points and the predicted values is near about less or same. So that is the thing where linear regression comes into picture. The formula which we use is y is equal to mx plus c, where y is the predicted value which is based upon the slope of the features, and c is the intercept. So there is a function into linear regression, that is linear regression dot intercept, which gives us the intercept of the line. The next is logistic regression. So logistic regression is a statistical model that in its basic form uses a logistic function to model a binary dependent variable, although many complex extensions exist. So in regression analysis, that is logistic regression, we use a logit regression function, which we are going to see how it is derived. This is the curve which we use into logistic regression. It is called as a sigmoid function, and logistic regression mainly works on calculating the probability of the class which is going to be predicted. For example, if our value lies less than 0.5, the class is going to be predicted for 0. But if it is greater than or equal to 0.5, the probability, the class is going to be 1. This is the derivation. Now I would be explaining. So f of x is the sigmoid function, that is 1 upon 1 plus e raised to minus x, and p of x is the logistic function which we get. Now the derivation is very simple. Like for example, we have p of x is equal to 1 upon e raised to minus x. So we are substituting x with mx plus c, that is the regression function which we used for linear regression. Then we just simplify it, and we are substituting mx plus c with h of theta. We get first equation, then we subtract it by 1, we get a second equation, we divide and apply some simplification techniques, so we get e raised to h of theta, so that is equal to e raised to mx plus c. We take logarithmic on both the sides, and we get the function as log of p of x upon 1 minus p of x is equal to mx plus c. Now this is the logit function which is in terms of logarithms, which is used in logistic regression. Now while predicting, as I said before, if the probability of x is less than 0.5, the class which we are predicting is going to be 0, and if it is greater than or equal to 5, we are going to get the value as 1. Now, before going towards the application, we would be seeing the implementation of logistic regression. Before that, before seeing the implementation, I would like to know if you have any doubts. Prarthana, are there any doubts in chat box?
No, Akshada, I don't see any. And if you have any doubts, you can unmute and ask directly whenever Akshada will pause.
Am I audible?
Yes, yes, you're audible.
This logistic function can be only used for binary classification or for others also.
Yes, it can be used for multiple classification also. Like it is just in terms of one variable, beta 1x. When we try to use for multiple, it's going to be beta naught. Beta naught is the intercept. Beta 1 is the coefficient for first feature. Beta 2 is going to be coefficient for second feature. So there are inbuilt functions which help us in getting the coefficient as well as the intercept of our function, of our model.
Actually, in case of more than binary classification, we will have to get more than two options like zero and one output. So is it
Your voice,
from?
can you repeat again, because I couldn't, your voice was breaking.
Okay, actually, I'm saying that in answer as output, we will always get zero or one in this case. But
No,
can it be used for other also?
yes, yes, this is a general scenario. Now, for example, if you're taking computer vision where you have to distinguish between fruits, for example, apple, orange, mango, grapes. Now, these are the four classes which we have. So it's not only about zeros and ones. It can be, the labels can be any. It can be in form of yes or no, spam or not spam. So spam or not spam is used in email filtering. Do you remember, like for example, if we mark a email spam, our machine learning algorithm, which is means the machine learning algorithm which is used in Gmail, if we get similar emails, they are directly marked as spam. So it's not only about zeros and ones, it can be anything. This is just a general scenario to make you understand. I hope it's clear. Hello.
I
Hello.
posted my doubt in chat.
All
Yeah.
right, all right. I'll check it. Just a second.
Can you please unmute and speak it out, because it will be difficult to switch the screen again and again.
Okay, so for four classes, yes, you can definitely use logistic regression for any number of classes. So it's not only
Okay.
about 4 classes, you can use for any. Okay, and there's one more question. What is the intercept and why do we need it? So basically the intercept is the point on the y-axis where two labels cross each other. So this helps us in determining the best fit line in linear regression as well as logistic regression. You must be aware about the slope point form. The slope formula, that is y is equal to mx plus c. So without intercept, we are not going to get a good best fit line for our algorithm. Okay, so any more doubts? I hope the SN your doubt is also clear. Okay, so anyone having any more doubts? Okay, then we can start with the implementation. All right, just a second. The runtime has been disconnected. I need to upload a file. No, it's already available. So we are going to implement logistic regression. Just to brief it again, logistic regression is a regression algorithm which is used for performing classification problems. And we are going to solve a problem whether a person is affected with diabetes or not. So to check that, we are going to use logistic regression. The logistic regression works on calculating the probability. So if the probability is greater than 0.5, the person is going to be affected, and if it is less, he is not affected. Then the metrics which we are going to use is accuracy, recall, precision, FN score, specificity, area under the curve, and receiver operator characteristics. I would be explaining it while implementing. So first we are going to import all the libraries. Pandas and NumPy are manipulation libraries. Logistic regression, train test, split, metrics. These are the libraries which are required for creating, building, and checking the evaluation of our model. Then matplotlib, seaborn. These are used for doing exploratory data analysis, that is for plotting the graphs. Now we are reading the data set using the command pd.read csv. So here we are having different kind of read statements. These are the parameters which we have. So it can be any, like it depends upon our data set which we don't want. We can also give a delimiter and get a file into the form of text or anyhow the way we want. Then data gives us the entire view of the data. Data.head will give us the first 5 rows. So the columns, the features which we are having over here is pregnancies, glucose, blood pressure, skin thickness, insulin value, BMI, diabetes pedigree function, and age. So talking about this data set, it is PIMA Indian's data set, PIMA Indian diabetic data set, which is tested, which is collected from all women's considering the pregnancies factors. The next is glucose level, which checks for glucose, blood pressure, skin thickness in Marathi we can say charbi. Insulin is how many insulin injections you had taken. BMI is body mass index, which we calculate using formula. Diabetes pedigree function is a function which takes into account the history of your means if any of your parents or grandparents had diabetes. This is the function, this is the calculation, this is the function which gives us that histories count. Now age is 50. For example, now let's consider first data set. If a person is having 6 pregnancies, her glucose is 148, BP is 72, thickness is 35, insulin is 0, BMI is 33.6, and she has a good means a medium history of like hierarchical what we say diabetes history in her family, and her age is also 50. So it's the outcome is likely to be positive. That is, she has high chance of being diabetic patient. Now, this was a part of reading the data. Now we are going to describe it. So data.describe is a function which helps us in describing the entire data set. So count gives us how many data points are available, that is 768. Mean is the mean of every parameter. That is, what was the parameter, what is the mean of pregnancies, glucose. We all know the formula for it. That is, we take the sum of all and divide it by n. Then standard deviation is we calculate the standard deviation for every column. One more thing, if standard deviation is 0, that column is of no use to us, so we need to drop that column. It is a part of data processing, pre-processing step. We have min, that is minimum value of that parameter. Then 25%, 50% and 75%. This helps us in detecting the outliers. These are the quantile ranges which we get. And max is the maximum value in that column. After that, we are going to check out for null values into our data set. So is null is going to return you into true and false. So adding a parameter sum will give you the count of how many missing values are there. We can see that there is no missing value into our data set. So that is a good. If there were some missing values, we had to process the data, which I'll tell you how to. Now we are going to do exploratory data analysis. We would be checking how the data is distributed. So this is a function which would be plotting out, which is going to plot out graph for every point, for every feature. Now we can see here, for example, in glucose and in insulin as well as skin thickness, BMI, there are some values with 0, which is practically impossible. Like there is no person in the world who has 0 insulin or 0 BMI. They are going to have some kind of values. So we can say that though our data set is not having missing values, it has 0 values, which are means impossible values. So we get this idea when we do the exploratory data analysis. So we can call this data set as skewed data. So we have to deal with it. The parameters which is glucose, insulin, skin thickness, BMI and blood pressure. They are having value as 0, which is not possible. So what we are going to do is, these are some of the pre-processing steps. Now BMI, blood, we are going to replace this data. Wherever the value is 0, we are going to replace it with the mean. Now many would be having the question, why mean? As these values are in the form of in the form of integers or numbers, we have to replace it with mean. Like we calculate the mean of entire column and then replace it to get better understanding. If we replace it with mode, that is the number of occurrences which we get, that is the maximum number of occurrences in the column, is going to be more skewed. Like for example, if 0 more data points are of 0, then there is no point in replacing it. So we are replacing it with mean. Now we would be checking our data set again. Just a second. Okay, so let's see the graph again. All right, so we have applied the pre-processing steps and we can see that there are no 0 values now. See, blood pressure, glucose, BMI, insulin, skin thickness, we have already replaced it and our data is now good. Now we have dealt with 0 values, but we can see that there are some outliers present. So outliers are something which are away from our data set. So how to check this? We would be checking it using box plot. So box plot gives us a good understanding about this thing. We can see that blood pressure, skin thickness, insulin, BMI, have outliers present as well as age. So we need to remove them. So these are the techniques. This is just a simple technique which I have created just to make you understand what kind of data pre-processing we can use. So in pregnancies, what we are doing is we are removing the quantile, that is 0.98 quantile over here. That is top 2% of data we are removing. We are storing it into a data cleaned variable. Then once the data is cleaned, we are going to check for BMI. We are going to remove the 1% data which we are getting, which we see from box plot. Same we are going to apply different. For example, on skin thickness, we are also removing 1% of data. We are storing it into data clean. Why it is necessary to store in data clean variable? Because we would be having an issue of range of values which are available. So that is the reason we need to update that variable every time. There is one more method which is called as interquartile range, where we remove the outliers using the quartile method. We subtract, we find out the data points which are above 75% and below 75%. Then what we do is we store those indices into a list, and using the drop function, we drop those indexes. So in that way also we get a clean data. Now we're going to check our data again. All right, so now our data looks more good. That is no outliers, no zero values. So now we can start with model training. We now sometimes there can be like when we remove outliers, we also lose some information. So we have to check it. Like for example, first what I do when creating machine learning models is without removing outliers, I check the accuracy of model, and after removing, I check the accuracy. If the accuracy which we are getting without removing outliers is better than the one which we are getting after removing outliers, we can means we can interpret that the outliers were important data points into the data, so there is no need of removing outliers over there. So this is the data pre-processing step which we do while implementing. Is anyone having any doubts regarding it before proceeding further, like for creating the models?
Can you please explain the data cleaning process once again?
Okay, so data cleaning is for this data set, the data cleaning was to remove we were not having any missing values, but we were having values with 0 as our data point. So in that reason, we what we did was we replaced those values with mean, because that's a better way. After that, if we are having missing values, and for example, when we have a data set, like the features are also in the form of binary, like into form of zeros and ones, and we have missing values over there, what we do is we replace those values with the most occurring numbers in that column, that is the mode. So that is one part of pre-processing. Then one more is checking the standard deviation. Now when we describe the data set over here, we couldn't find any standard deviation as 0. If it was 0, then we need to drop that column, because it is of no use to us. Then we also have a check. Now in this data set, as the file was already ready, we were not sure for cleaning about it. Now when we have the file in the form of text data, so we need, for example, if you are doing any kind of information extraction, whatever the words which we are requiring, we are going to clean them using regex pattern. So regex pattern is something where we give our own grammar, like for example nouns, removing the stop words, removing the tokens, and then tokenizing the sentence, and all that things comes into NLP part. Into this also, the one more thing which I told was data balancing. So this data is already balanced. If the data is not balanced, we have to balance it. So we can use different libraries called random undersampler, oversampler, then smartomic, it is smart en, and there are many libraries and many algorithms which we can use. So data cleaning is not that you have to follow only these procedures. There can be another also. Now there's a research paper where outliers are removed using k-means clustering. So you have to think something out of the box and try to make your model more accurate, and also considering it doesn't require a lot of time, also the space required is less. So I hope you understood it.
Yes, I got the point. Even when we use regularization or maximum or minimum scalars, will that also work in the same way?
Yes, so when you do those things now, what you have to do is whenever you take input. Now, for example, if you standardize or normalize the data set, now the input, that is the array of values which you provide to the model, changes entirely. So when we do that, we have to also standardize or normalize our data set into in the production also. Like for example, if you just consider this example where we are normalizing it, now the value is in terms of just a second, okay, so it's going to be 6, 148, 72, 35. These are the values which user is going to input. Suppose you use those techniques, these values are going to change, means it's going to come around in points. For example, 0.6, 0.148, but the user doesn't knows now what is standardization. So we have to standardize the input also, and then the values which we get, we are going to give it into our model. Is it clear? Hello?
Yes, yes, I understood.
Yeah. Any more doubts?
No, no, thank you.
Yeah. Anyone else? Okay, so I hope everyone has understood these steps. Okay, now what we have to do is we have to separate our data set. That is, we have to separate the data set into features and labels. So we are dropping the column outcome, and we are going to now visualize the relationship between independent variables and categories. So we are going to check how means what effect our value is going to have on outcome. For example, over here, skin thickness. So values ranging from 0 to 60, from 20 to 60 in this frequency are going to give us, means these parameters are going to give us 0, and the orange ones takes us to class 1. Similar for insulin, values between 0 to 600, which gives us 0 and 1 as outcome. Now the points which we can see are which are far away, like for example these 2 points in insulin, then in diabetes pedigree function this orange points, these are something which we cannot call as outliers, because they are going to give us some important information which we need to retain it. Now once we check this relationship, we are going to split the data. Now we use the train test split library for splitting the data. The test size which we are kept is 75% of the data is going to be used for training, and 25% of data is going to be used for testing. The stratify parameter is going to give equal values, like 75% of y's equal, means zeros and ones are going to be into equal proportion for both testing and training. We are going to call the logistic regression function. So dot fit, we are going to fit the model on X train and Y train. Once we have fitted the model, we are going to get the predictions on X test, that is our training set. Now we are going to compare, I'll show you the Y pred. So this is the array which is generated after prediction, and we will be checking for Y test also. So we can see that our first value has been predicted correctly. Second also, Means in this way we can check if our values have been predicted right or wrong. Now we are going to check for the accuracy. So accuracy, this is the inbuilt function accuracy score, which gives us the accuracy of the model. So we have achieved 73% of accuracy on our model, which is good. Like as we have done some pre-processing steps which were not necessary, just to make you understand, this is the reason which we why we are getting 73%. Now confusion matrix. So confusion matrix is a matrix of true positives, false negative, and true negatives. So it helps us in distinguishing how many values we have predicted correctly and wrongly. So the first, that is 102, is our true positive value. That is, the actual and predicted value is correct. Means we have predicted a positive class, which is actual as well as predicted. False positive is where we have predicted positive, but in actual it is negative. So it is called as false positive, which is also known as type 1 error. In false negative, what we do is we predict negative value, but that is wrong class. But actual it is positive class. So it is known as type 2 error. And in true negative, the actual as well as predicted class is negative, so it is known as true negative. I know it's a bit confusing, but confusion matrix helps us a lot in getting how many values we have predicted correctly. Now if we see here, true positive is 102 and true negative is 40, so it comes around 142 values were predicted accurately and around 50 values were predicted false. That is, so we have to check with the model again so that these values are reduced. That is the false values. Now we would be checking out the evaluation metrics. So we are of the accuracy which we used over here. For example, this one. This is the inbuilt function which we are using. Now we would be looking out towards the formulas. Accuracy is the measure about how often the classifier is predicting correctly. So it takes into account only true positive and true negative, and it is divided by all the four values. It is 73. So we can say that the value which we are getting using library functions and using a formula is same. Next, precision. So precision is how correctly the classifier predicts cases actually turns out to be positive. So we are checking out for true positives over here, and the formula goes like true positive upon true positive plus false positive, which gives us the precision. So it is 81%. So we have to get the percentages, we have to multiply it with into 100. Recall. Now in recall, we get the actual positive cases which the classifier was able to correct, which were able to correctly predict with model. It is also known as sensitivity. Okay, so it comes around 79%. F1 score is a combination of both, that is recall and precision, and we can also call it as a harmonic mean of recall plus precision. AUC ROC curve we use. So AUC is area under curve, which helps us in distinguishing different classes. And for ROC, now what we do in ROC is a probability curve that plots true positive rate against false positive rate at various threshold values and separates the same from the noise. So we get it using inbuilt functions. We plot the graph and we can check for the curve. So this is the ROC curve. Now, what is the significance of ROC and AOC curve? So in real life, when we are not just going to, now for example, taking this Pima Indian data set, On logistic regression, it is giving us 73% accuracy. But when we use decision tree or some another algorithm after doing hyperparameter tuning and all those stuff, we might have a chance to get more better accuracies. And I have checked with the research papers that using more other algorithms, using stacking, boosting, packing, we get an accuracy of around 95% for this same data set. So to find out which model is going, which is best, we use ROC and AOC curve. So we use AOC to determine which model is best one for a given data set. For example, we have created logistic regression SVM and clustering model for classification purpose. We will calculate AUC for all the models separately, and the model with highest area under curve will be the best model for us to use. Now, the advantages of logistic regression. It is very easy to implement, as you have seen, as compared to decision trees, clustering algorithms, and other unsupervised algorithms. Then the output which we get is more informative than other classification algorithms. It helps us in expressing the relationship between independent and dependent variables, and it is very effective with linearly separable data. The next is, what are the disadvantages of logistic regression? So it is not effective with data which are not linearly separable. It is not as powerful as other classification algorithms. When we, for example, random forest has a good, means it helps us in preventing overfitting and underfitting thing. So we can take that into consideration also. Multi-class classifications are easier to do with algorithms than logistic regression, and this can only predict categorical outcomes. So, do you have any doubts regarding this algorithm? Hello, yes, anyone wants to speak? Are there any doubts in chat box? Hello?
No, it is clear.
All right, all right. So, fine then. We have already come to an conclusion. Now we would be looking out for applications which we can, which are used in machine learning. So there is no any for in today's world, we can see machine learning algorithms which are used everywhere. For example, healthcare to predict different diseases. Then we can use healthcare integrated with augmented reality and virtual reality also. For example, have you heard about the remote doctors experiment which was conducted in China, where the doctor was in another country and he was performing surgery in some another city. So this is an example of artificial intelligence integrated with AR and VR, where where the research is going intensively, and if it comes into production, it's going to be very useful in India, because we know the doctors in India are quite low as compared to other countries, and the population and doctors ratio is very small. So considering this, we have to create humanoids, robots which can be used in healthcare sectors also. If we have different systems, like for example predicting diseases, checking out the trends into the diseases, then using various ML algorithms, we can predict those. This can help the doctors in means in filtering out the patients who are affected and not affected. If the person is affected, they can give him early treatment, and it can help the person in means it can help us in increasing the life expectancy rate of our country. The second is in security. So in security, we can see in our army we have different types of products. For example, drone we classify various images using ML algorithms. So that helps us in finding out different flaws which are present, or also in terms of security. In NLP, the best example is Alexa. Robotics, so in robotics, when we create humanoids, personal assistants, the nurses which help in different people, mostly aged people, we can use artificial intelligence over there in wide range. In recommendation systems, for example, Netflix, Instagram, Facebook, whatever the recommendations which we get after watching reels, movies, there we have an intensive use of machine learning. In finance sector, we help in getting the business demands, calculating the stock prices, forecasting it. In e-commerce sectors also it is very useful, where we can give the recommendation of products which Amazon does, even Walmart does. In automation, where we have to automate a process, like for example, uh, auditing different reports using a machine learning algorithm, we can do it within seconds. Also forecasting. Also, now in previous days there were things like, for example, we had to analyze the data manually, but using some code ML algorithms we can analyze it as early with the help of machine learning. So I can say that machine learning is not a one day thing. You have to continuously read about it. Every day a new parameter is added into a model, the research has been upgraded, we have statistics behind it, calculus is there, then there are plenty of algorithms which we have to be very much, means we have to be updated with those things. We have to check what kind of research is going on, what updates you can, how can you update those previous research which can help you in publishing research papers. This is the thing. So it's going to be a vast field, and I would suggest is like start from basics and then read about it, and you can be a master. Yeah, so it's not just a small cup of tea, it's going to be huge. So yeah, with this we have come to an end. And okay, so for resources, I had completed my machine learning masters from iNeuron. Around, it's a 6 months course where we were introduced with everything, like starting from Python programming to database management systems, machine learning algorithms, an overview of natural language processing, deep learning, as well as taking the data science projects into real time. Yeah, I forgot to say that when we have real time data, it's very hard for us to monitor it every 5 to 10 minutes. That is the data which updates every 5 to 10 minutes. We need to take it over some wide platform. So for that you can use Spark. In that Spark also there are a lot of inbuilt libraries. For example, Spark streaming helps us in creating relational data frames which can be updated accordingly. Like for example, if you want to get the data every 5 minutes, you have to create different 5 minutes RDDs. Then over that RDD, we can use ML algorithms according to our use. Spark has inbuilt libraries for machine learning, natural language processing, and deep learning, where models are already trained. You just need to give your parameters and you get an output. So Spark is one of the best tool which we can use in data science for getting good results in minimum amount of time, and it has a good processing power also. Okay, so is anyone having any doubts?
No, it's clear.
All right, so I would be sharing the course link, just a second. Till then, Prarthana, you can take up.
Yeah, sure. And Akshada, I remember you have also shared multiple resources and your entire machine learning journey on the GDSC AISSMS IOIT's website.
Yeah, right.
So what I'll do is I'll quickly share your blog link so that all of you can read it and learn about what resources you can access and what resources you should opt for continuing your journey with machine learning.
So I have shared a link of iNeuron. So it is a startup which they are developing their own courses. So you can find a wide range of courses in data science, development, cloud, DevOps, programming, marketing. In data science, you are having courses like full stack data science, machine learning, deep learning, computer vision, AI ops, stats, NLP, data analysis, big data. Also you would be getting some tools like visualization tools. Now for example, when you have like you have decided you have to go into data science field, you would be there are posts like for example data analyst, the one who is into deployment completely, the one who creates algorithms completely. So depending upon your interest, if you are very much clear that you want to become a data scientist, you have to be proficient in all those things. But if you want to get into a part of this, for example data analyst, for that you have to be clear with different data analysis, different visualization tools, for example Tableau, Power BI, these are used. Then for model making, you have to be the one who has information about all the algorithms. Then the one into deployment, so he has to know each and every deployment feature, for example streamlit, how to deploy it over AWS, how to use it on cloud resources. These all things, all these courses are available. Now if you also want to get to know the algorithms in depth, so you can opt the statistic course which is available over here. For and another way to this is, if you don't want to waste your money over these courses and you have a basic understanding of ML, what you can do is you can navigate through Krishnak's YouTube channel, which is one of the best resources which I have encountered for machine learning algorithms. He teaches from scratch with all the stats and calculations along with implementation. Also, he has end-to-end projects which helps us in creating the models and deploying it over uh, Heroku, Streamlit, or even the Kite platform. So you can check out for that also. Even that is a good resource. I'll share the link for that too.
Okay, by the way, just interrupting here that we are in no collaboration or partnerships with the company names Akshada is mentioning. It is just that we want to share the best resources with you, like the resources our speakers have gone through, our core team members have experience with, and therefore we are sharing it, and we are in no collaboration with them.
Yeah, so these courses I personally felt are very good, and they also have an internship platform. But now it's an open platform where you have to do your own projects. When I was interning, we were allocated with managers. We were working into the company's products. But now what they do is they there are some problem statements. If you solve them and post means give the product in relevance to their documentation, means the way they want, you would be getting an internship certificate from them too.
Okay, can you share the Google Colab link which you used today?
Sure, I'll be sending it into the WhatsApp group. The only thing is, I had added the folder from my own side. I would be adding the dataset link as well as the collab link. So you need to either, if you're using Anaconda, you can directly store the dataset file into the directory you're working, or if you're using the Google Colab, you have to upload the file and then use it.
Okay, but I am not in any WhatsApp group.
All right.
Yeah,
Okay
me
then.
too.
Raj, I'll share the link. I'm
Okay, thank
sharing
you.
the link of the WhatsApp group, and also I'll share the link of our event platform so that you can be a member of GDSC AISSMS IOIT.
Can you please reshare that link? I want to be the member of that, and also I also don't have the WhatsApp group link. I was worried about the day two event because I don't have any mails regarding that. So I was worrying how will I join the day two event and all.
Pranjal, how did you get to know about this event?
Actually, I was just surfing on the web about Google Developer Student Club because of my I and my friends were looking for different fields. So I came to know that there is something regarding machine learning. As it is my own domain, so I got something to learn and brush up my whatever I have learned. So that's how I came to know
That's
about it.
great, Pranjal. So I'll also share the event platform link so that you can be a member of RGDSC, and further you'll also get mails about all the events that we conduct.
That would be perfectly fine. And thanks to you.
I have one doubt. I'm getting mails of all the events that you are organizing. So I am a member of that GDC group, no?
Yes, if you are getting all the mails, that means you are a member.
Okay. Thank
You can check it out once. I'm just sharing the link over here.
Yes, that would be grateful if you share that in the chat box. So we'll be able to join it.
Yeah, I have shared both the links over here, and also you'll get the links for all the resources that Akshada has shared in the WhatsApp group itself. So join it quickly and stay tuned. Akshada, do you have anything else to share?
No, means I have been using only these resources and some blogs which we get. Means if you get any doubt, we go towards the Medium blog post. So those are the things resources which I am been using, and some books which I have taken from our college library. Nothing apart from this.
Okay, that's really great, Akshada,
Bef-
and I hope everyone who was attentive throughout the session has got some really good insights on machine learning. And now I think you are ready to kickstart your journey in machine learning. And I'm very thankful to Akshada for making time and helping you all kickstart your journeys. And also thanks to the whole team of GDSC AISSMS IOIT for making the event smooth. And see you all tomorrow at 10:30 a.m. for deep learning workshop, which is a continuation of today's workshop, and will be hosted by Aditya, who is also the co-lead at GDSC AISSMS IOIT. And this is not it. Tomorrow we'll also be having a quiz at the end, which will cover all the concepts from today and tomorrow to test your understanding. And those who win the quiz will get a chance to win GDSC branded t-shirt and some GDSC branded stickers as well. So make sure you join tomorrow. Thank you for attending. Bye everyone. Have a good day.
Thank you so much. But before you
thank
end
you.
up, I would like to ask a last question, if you don't mind.
Yeah, sure. Go ahead.
So will you be covering that unsupervised learning and semi-supervised learning concepts also by tomorrow? And
Uh,
will you be taking on the advanced level or just basic to intermediate level?
s-
So,
okay, so
this was just basic to intermediate level, but if you want to learn in advanced as well, so you can maybe write to us on the event platform. There is a button to contact us, so you can do that. And apart from this, GDSC also hosts a global machine learning event annually. So, in that event also you'll get to learn a lot. So this was just a basic session from scratch so that you get to learn the basics and so that you can kickstart your journeys.
Sure. Thank you so much for the clarification. Once I join the group, I will be clarifying with you that how I can learn with the advanced level. Thank you so much.
Okay, all right. Thank you. Bye everyone. Have a good day.